Okay, so I've talked about the importance of creating a scatter plot. So here is a blank scatter plot, and we need to know how to do this on our EOC. So the most important thing that you should know, and you should already know this, you need to label this Y and label this X, and that's so easy to do. Okay, so this is a table showing the amount of storage and cost for flash drives at an electronics store. Okay, so we're just going to title this, whatever this says, flash drives. Next, your first box is always your X. Your next row is always your Y. So for my X, I'm going to call storage. I don't need that so close. In megabytes, my Y is going to be cost in dollars. Okay, we don't know what these increments are until we look at our data here. So my X data, the highest number is 16. And do I have 16 spaces here? So we can go 16. I think we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16. So yeah, I'm just going to go up by ones. There we go. On our Y, let's see what our highest value is, 42. So I need to go up to 40. I know this is probably not 40, but let's see what we are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20. So I could go up by 2s to get to 40. I know this is super annoying, but this is what you have to do. What did I say? 42 is our highest? Perfect. All right, so now we can plot these points. So when we're plotting these points, we're taking these X and Y values. So the first one would be 2, 6, and then 2, 7. So let's go ahead and plot these. Do that on your own. I'll give you a second to do yours. And then I really need you to get some sort of a straight edge. So I'm going to dig for mine, and if you need to stop this and dig for yours, it's going to be important. Okay, I'm going to draw a line of best fit. So it needs to go kind of in the center of everything. So if you look at this here, the center would be somewhere around here. Center-ish, center-ish. So I look at the center and just try to do my best. So I have the equal number on top as below. Okay? Now, that's my line of best fit. Now, I need to determine 2 points on this line that I can use for my equation. This y-intercept is a good one. I'm going to follow with this one's, ooh, here's one right here on mine. Yours may not be, but see how mine crosses exactly right here? And this could be different on yours because you have a different line. Here's another one. It doesn't matter, but pick two that are exactly on the line and make them bigger. So these are the lines, these are the dots you're going to use to find the slope. Now, I can use them as points and use the slope equation, or I can do my rise and run. Now, if you do the rise and run, you have to realize that I'm going up by 2, so that can be kind of tricky. You have to think about that. My first point I'm going to have as 0, 6. And my second point, what is that? 7, 18. So slope formula is y2 minus y1 over x2 minus x1. This is my x's, and these are my y's. Okay. So I'm going to say this is my second point. So those are my 2's. These are my 2's. So my y2 is 18 minus 6 over x2 is 7 minus 0. 18 minus 6 is 12 over 7. So that's going to be my slope. Okay. If I did it from rise over run, I'm going up 2, 4, 6, 8, 10, 12. So same thing. And then over 7. So exactly the same thing. So I don't care how you do it, you're going to get the same slope. So I just determined my slope. I forgot I had this box. Okay, so now I have my slope, which is 12/7. Yours could be very different than mine, but it's going to be very close to mine. I guarantee it. My y-intercept was 6. I didn't have to show anything. So my equation is y equals mx plus b. B is the 6, m is my slope, and then it's just inserting that y equals, and here's my final answer. Takes practice. And then they might say, okay, what if you had 20 millibytes? Then you would just insert the 20 into the x to get how much it would cost. And that's how you do it.